All right, 3-5 is all about 3 space. Now, some of y'all's brains are about to melt. Graphing in 3 space is kind of tough. In fact, the first thing you'll see these coordinate planes, but they're not even coordinate planes anymore. This is coordinate 3 space. Now, you'll see we got the x, the y axes, and this is the positive x axis. This is the positive y axis. So, to put this in perspective, this is here, this is quadrant. If we're just looking at this green thing, this is quadrant 1. Then if we were to make this axis continue back, this is quadrant 2. And then the y-axis, if we were to continue the y-axis going this way, this is quadrant 3. So that makes this right here, this is quadrant 4. Alright, so this is the coordinate plane, but then there's a z-axis that's coming up off of it. And the z-axis measures height. Right, so you can see that the coordinate plane got turned and rotated, but this is quadrant 1, 2, 3, and 4. These are positive x and y axes. This is also the positive z axes. All right, so hopefully that kind of puts it in a little bit of perspective as to what we're doing here. So the point 2, 3, 5. This is an ordered triple. There's 3. Now, ordered triples are x, y, z. So this is a point 2, 3, and then they're adding a 5. So this is the point 2, 3, just like we've always done on the coordinate plane, 2, 3. But then it's risen 5 units off the bottom. Now, this is going to freak some of y'all out. So you notice that when they went 2 this way, they went 3. Now, they went 3 along the y-axis. Now, this is 1, 2, 3. Here's 3 right here. The reason why this is 2 is because 1, 2. 1, 2, that's 2 across here, and then 3 across because this is 3 here. Now, why is this point in front of this? Remember, it's all about perspective. If you think about this, we're actually floating above and to the right of the coordinate plane here. All right, so because we're floating above and to the right, our perspective got shifted a little bit. So it's not just a straight out boom 3 like this. We have to go parallel to the x-axis to get this point here. Then when it rose 5, it's saying that this is 5, but if you look here, this is 1, 2, 3, 4, then there's 5 there. See how 5 is higher up than it is here. That's kind of strange, right? But let me explain what's up here. Up here at 5, draw like a dotted line parallel to the x-axis. And then from x here, draw a parallel line, parallel to the z-axis going up like this. And you'll see that it doesn't intersect at quite a right angle. But where it does intersect, go across, and that should go and intersect that point. Now back here at z, go parallel to the y-axis again. And from the y point, go up like this. And you'll see that what's happening is we've actually made a box here. This point is kind of like the corner of a box that is 2 by 3 by 5 units tall. This is the corner of that box. Now, y'all, some of you are really going to struggle with this, and I totally get that. Some of you are going to have a hard time drawing this. It's going to take practice. All right, so let's go to number 2 here. 4, 5, 2. The x-axis is 4, so we're going to go across 1, 2, 3, 4. There's 4 right there. The y-axis is 5. 1, 2, 3, 4, 5. So, from x being 4, go parallel to the y-axis across like this. And then from where y is 5, go parallel to the x-axis like this. And that intersection point, that is the point 4, 5. That is the point 4, 5. Now, from that point, we have to go up 2 units. So, up 2 units will be something like that. How come it's not all the way up here? Again, it's the perspective of where we're at. Hey guys, if you can make this parallelogram, that's all that I need. And then if you just want to write this stick going up saying that you went up two units, that's fine. All right, but the minimum that I need is this parallelogram, and then I need you to tell me that it rose up 2 units. Now, why is it floating up here? Again, remember, up here at 2, if we go parallel to x and parallel to y, we get the makings of a box, right? So maybe I should have went a little bit higher, but that box is hanging out like that. It's 2 units high. Remember, parallelogram and then go up. All right, so let's try these 3. Number 1, I'm going to do in purple. The point 2, 3, 4. 2 right here, 3 going across on the y-axis. Go parallel to the y-axis. From y is 3. Go parallel to the x-axis, and there's our parallelogram. But then we got to go 4 units high. So 4 units high, we'll say is like that tall. There's the point 2, 3, 4. All right. Try out 2 and 3, and then check yourself with mine. All right, so number 2. -5 along the x-axis. -5 goes backwards. 1, 2, 3, 4. There's -5. 3. 1, 2, 3. So from y is 3, go parallel to the x-axis. That wasn't very parallel. From x is -5, go parallel to the y-axis, and that's where it's hanging out. Then 4 units up this way is going to be like this. Now, wait a second, Smith. If the purple one is up 4 and the green one is up 4, how come the green one's up way up higher? Remember, it's a perspective. It's where we're hanging. We're floating above and to the right. And this corner is closer to us, so that's going to look lower than what it does back there. I know it's a weird concept. Y'all get used to it. All right. Number 3. X is 1, 2, 3. Y is -4. So we're going to go 1, 2, 3, 4 this way. From here, parallel to X. From X is 3, go parallel to Y. There's the parallelogram. Down 2. So from this point, we're going to go down 2 units. If you want to just say it went down -2, that's fine. So if you want to put 4s to tell me how high up it went like that, that's totally cool. All right. Plotting points. That's the hard part. Even though it's the first thing, that's actually the hard part of this lesson. Now, we're going to graph the following equations. Now, think about it. If we graph y equals 2x plus 4, that makes a line. 2 variables make a line. Well, here's the thing. Here we have 3 variables. 3 variables are going to make... We'll talk about that in just a minute. First of all, this is kind of like standard form, like a souped up standard form. Remember standard form? If we made this -2x plus y is equal to 4, that's like a pseudo standard form, right? We would do the intercepts. Remember the intercepts? We're going to do the same thing here, but we're going to do it with triples. We're going to make intercepts with triples. All right, now, check this out. When x is 0 and y is 0, what is z? When x is 0 and z is 0, what is y? And what is x when y is 0 and when z is 0? So check this out. In each order triple, we're going to put in 2 zeros. The question is, you got to find out what x, y, and z are. So when x and y are 0, you get 2z is 6. Z is 3. All right, when x and z are 0, negative 2y is 6, y is negative 3. And then x is equal to 6 when y and z are both 0. All right, so we've got 3 ordered triples. What we're going to do is we're going to graph all 3 of these points. Now, these aren't as bad as those other ones before. 0, 0, 3, that's just the z intercepts. Right? The y intercepts is 0, 0, negative 3. There's our y intercept. And then we got the point 6, 0, 0. 1, 2, 3, 4, 5, 6. Now what we've got here is 3 points. And if you recall from geometry, any 3 points, any 3 non-collinear points make a... Connect these dots. They make a triangle, yes, but they also make a plane. This is a plane. Think of this as a sheet of paper that extends forever in all directions. All right, this is kind of slanted. If we were to stand on this plane, we would fall down this way. Right? So the easiest way to draw a plane is you find the 3 intercepts, you plot those points, and make the triangle. So number 5, give that a shot yourselves. Go ahead and press pause. Come back and check yourself. Zero, 0, negative 3. 0, 4, 0. I think you got negative 6, 0, 0. So plot those 3 points. 0, 0, negative 3. 0, 4, 0. Dang, it's way back there. This is a plane like this. So tell you what, if I was to drop you in and you were to stand on top of this plane, which way would you slide? You would slide towards the axis here. This is kind of slanting down like that. Alright, that brings us to our next phase. Next phase is write the equation as a function of x and y. This means solve for z. Then evaluate f of negative 2, 2. Now, what does this look like? This looks kind of like function notation, right? Let's pause there. First of all, it says write the equation as a function of x or y. That means solve for z. So let's get this bad boy. Let's solve for z. So 3z equals 30 minus 9x plus 12y. All right, then get z by itself. You divide by 3, so you get z is 10 minus 3x plus 4y. Now, another way to write z is going to be f of xy. Z is a function of both x and y. So f of xy is 10 minus 3x plus 4y. That's our function of x and y. So now, the next thing that they want us to do, what is f of negative 2, 2? Well, f of negative 2, 2 is going to be 10 minus 3 times x. Negative 3 times x is plus 6. 2 times 4 is plus 8. So f of negative 2, 2 is 24. X is equal to 24. Alright, so the last example here is a word problem. Don't let it scare you. Go ahead and read that. Give it a shot. We'll talk about it in class. Smith out!